Hello everyone, welcome to the coding channel. In this video, we will be solving the problem spiral matrix. The number is 54. The problem statement is given an m by n matrix, return all the elements of the matrix in the spiral order. If you look at example number 1, the input is given in a 3 by 3 matrix with all the numbers starting from 1 all the way to 9, and we need to return a list of integers. It needs to be in a spiral order, and when I say spiral order, it will start from the top left corner, go to the right, and then bottom, then left, and then top. We need to make sure that we are not iterating over the same elements again. Like in example number 2, we have a rectangular matrix where m is 3 and n is 4. So we start iterating from 1 all the way to 4, then 8, 12, then we go to the left, 11, 10, 9, then we go upwards, 5, because after 5 we have 1 and 1 is already being covered, so we won't be doing 1. Instead, we will switch to the next direction and move right. And that is how we need to iterate through all the elements in the matrix and return the result. This is a medium problem, but trust me, once we go through the explanation and the solution, it wouldn't seem like a medium problem, it would seem like an easy one. So without wasting any time, let's switch to the whiteboard and discuss the possible solution. We will be using the example given in the problem statement. If you notice the way spiral matrix or spiral iteration works, it starts from left to right, then it will go from top to bottom, then from right to left, and then from bottom to up. These are the only 4 directions that we need to follow, and we need to make sure that these directions are followed in the right order. We cannot be deviating from this order to complete the spiral iteration. If we were to break it down and just focus on one direction at a time, if I'm moving from left to right and if I have 2D matrix of m by n, so in that case, my m will be constant and I will be iterating with different values of n. If I'm iterating from top to bottom, in that case, my m will be variable and my n will be constant. Just like the iteration from left to right, when I'm going through this iteration, I will have a similar loop, but it will be going from back to front. I will have a constant m and n will be variable. It will be decrementing. And the same logic goes for bottom to top. If I break this iteration into these smaller problems and solve it separately, this solution will not seem that difficult. Now let's talk about how we can do that. I have created a variable called direction and I have defined 4 values. 1 means that the iteration is going to be from left to right, 2 will be from top to bottom, 3 will be from right to left, and 4 will be from bottom to top. If I start the iteration in this matrix, I know it needs to start with the direction 1 because the spiral starts from top left to top right. So my initial direction is going to be 1. So for 1, what I need is a constant m and a variable n. And before I begin the iteration here, I will be defining few default variables. So I will have m as 0 and m max will be 3 because I have the matrix as 3 by 3. So the maximum is going to be 3. Similarly, I'll have n as 0 and n max as 3 as well, and of course have the direction too. So by default, I will have my direction as 1. These will be the default values when I start the iteration. Here, I will have m as my constant and I will be looping through all the values between n to n max. So here my n is 0 and max is 3. So I will run the for each loop, iterate through all the elements and save it. So with this value, my output will have 1, 2, 3. Now once I'm at 3, I will run out of max and I will stop the iteration with the direction 1. After direction 1, I know it needs to go to direction 2. But before I do that, I need to do some changes to my default values. Because I have already completed the iteration of the first row with direction 1, I need to do is increment my m or m minimum by 1 because I don't want to iterate through this row anymore. I will increment my m and it will now be 1. I am at direction 2. For direction 2, which is top to bottom, I need m as variable and n as constant. So my n in this case is going to be the n max. N will be 3 and m is going to iterate from m to m max. So my m in this case is already incremented by 1, so it is 1 and then my max is 3. I will be iterating between 1 and 3, which will give me 6 and 9. I hope you are able to follow me. So this is going to be an incremental for loop where I will increment my m counter by 1 every time. So I will first be pointing at 6, then at 9. So after 3, I will have 6 and 9 with direction 2. And once direction 2 is complete, it means I have already iterated through this column. So I need to decrement my n max by 1. So here I will do n max minus minus, which will reduce the n max to 2. And I will change my direction to 3. For direction 3, it is going to be right to left. So I'm keeping my m constant and n is going to be iterating between n max and n. Because it's from right to left, it means I need to do a decrement. So it's going to be starting from the higher node to the lower node. So here my n max is 2 and my n is 0 based on the values that I already have in the variable. If I start the iteration here, I will be getting 8 first and then 7. So my next set of values in the output is going to be 8 and 7. And after this iteration is complete, after the loop is complete, I would have completed the iteration across the row. So I can go ahead and decrement my mmax counter. So right now my mmax is 3, it will become 2. I will just erase some spots here so that I have some space to play around. After 3, we know we need to go with the direction 4, which is bottom up. So with direction 4, I am keeping my n constant and iterating between m. And because this is a bottom up, I will be doing a decrementing from m max to m. So my current m max is 2 and m is 1. So it is going to be 2 and 1. And the only value that I will get from this iteration is 4. I will add the 4 in my result. After the iteration for direction 4 is complete, we can mark the complete column as done and move next. And because I am marking on the left side, I need to increment my n by 1. N right now is 0, now it will become 1. After the direction 4 is complete, I will go back to direction 1 and continue the same loop again, but with a different set of values for m, max, n and n max. So in this case, after I have added 4 and I'm at direction 1, my m is going to be constant, which is 1, and I'm iterating between n and n max. So here my n is 1, n max is 2, which will give me the value 5. I will take that value 5, add it to my result. We need to run the iterations on all directions until we have the same number of elements in our return variable as we have in our matrix. Here in the example that we are using, we have a 3 by 3 matrix which will have 9 elements. So once I have 9 elements in my return variable, I need to break the loop. I hope you were able to understand the way we broke down our problem into smaller sub-problems and solved it separately. The time complexity with this approach is O of n because we are iterating through all the elements in the matrix only once and not multiple times, and our space complexity is O of 1 as we are not creating any variables to save collections of results. All we are doing is having these four temporary variables to hold the values of the boundaries of m and n. Let me show you how it can be implemented using C#. Here is the equivalent solution in C#. In the main method, I start with checking or validating if my matrix is not null, if its length is greater than 0. Then I initialize few variables, max, n, and nmax. So I'm calling it in using different variables: top row, right column, bottom row, and left column. And then the variable for direction. Then I start with a while loop, and this loop will run until I have the right number of values in my return variable and comparing it with m into n. Within the while loop, the first iteration we do is with direction 1, which is top left to top right. Here I'm starting from the left column, which is n. I'm running it until we touch the n max. And for all the iterations that we do, I'm adding the values to the return variable. And once this is done, I am incrementing the top row because the iteration is complete, and I set the direction to 2. If the direction is 2, I do a similar approach, but the iteration is across the rows. So I'm incrementing my rows, iterate through the values, add it to the return variable, and then decrement the n max because the column is iterated. I have a similar loop for direction 3 and direction 4. After the iteration is complete, we will return the return variable as it will have all the values in the right order. Thank you for watching this video. I hope you were able to understand this approach and the solution. This solution is very much simple once we understand how it can be broken down into smaller subproblems, and I'm sure you must have noticed that too. If you have any questions or concerns, feel free to reach out to me. I will be adding the link to the source code in the description below, so you can check that out as well, and I will see you in the next one. Happy coding!